Let's review for exam 4. First question is saying the gamma ray emission from the decay of cobalt-60 is used in cancer therapies. Cobalt-60 decays by the emission of 2 gamma rays followed by beta emission. What is the final product of this decay process? So cobalt-60 will emit 2 gamma rays. Gamma rays have 0 protons and 0 mass. So nothing will happen after 2 gamma emission, so don't worry about this part. Then the next is beta emission. Beta emission, you have this for beta emission, -1 and 0. And don't forget to memorize the symbol and the charges and the mass for all of these emissions. So beta, when you have beta emission, means that cobalt is 27. You need to have a balanced equation. -1 plus what gives you 27 plus 28. And here you have 0 and you must have a 60. So the only thing that has, the only particle given that has these 2 numbers on it is nickel, so D is correct answer. Question number 2. When the radioactive nuclide polonium-198 undergoes alpha emission, it's 2 here and 4. Again, you need to memorize them for the test. They're not gonna be given. So you must balance them again. Polonium has 84 protons. So what should be added to 2 to make it 84? 82, and here 198 minus 4 is 194, and it's the characteristic for PD. So again, D will be the correct answer. For number 3, the question is saying which of the following nuclides is most likely to be radioactive? In order for a nuclide to be radioactive, we must go to the ratio of N to Z. You must pay attention to this. Choose the marker. The ratio of N to Z must be equal or greater than 1.5 according to what you had. The only, if you check all of them, the only particle, the only atom that has N to Z about 1.58 is radon. Radon 222 and Z is 86. So don't divide this by this. This is not N. This is Z plus N, and this is Z. So you would do 222 minus 86 divided by 86. This ratio is going to be 1.58 for this radon. So this is, so make sure you subtract this from this and then divide by Z. This is not N. This is Z plus N. So again, D is the correct answer. For question number 4, for which of the following radioactive decay processes does the atomic number not change? For electron capture, positron emission, alpha emission, beta emission, they all change the atomic number except the gamma emission, which is 0 and 0. So it's whether emission or whether having the gamma in the reactant side. 0 and 0 is not going to change anything. So again, D is the correct answer. For question number 5, Question number 5. A nucleus located to the left of the band of stability is expected to undergo what type of nuclear decay? The answer is electron or beta emission, E. Just refer to the graph you have on the PowerPoint slides. You need to know that graph. Number 6 is from chapter 23. Which of the following is an example of a condensed formula of an alkane? They all show the formulas of alkane, but the condensed formula does not have any ball and sticks like C does not, and D, and does not have any lines. So the only one which shows the condensed formula, it says condensed as, you see there is no bonds, nothing. It's just a combination of atoms and subscripts is going to be E. And you might say, well, how about C3H8 is not the condensed formula, it's just the formula, general formula. So E is the correct answer. For question number 7, what is the major product upon addition of HCl to propene? First of all, we need to know the formula for propene. We have memorized the formula for propane. If it was propane, it would have 3 carbons. Now this is propene, so this is an alkene. We have this formula. Or if you want to know better, we have, this is propane, okay? The alkane. So in order to change propane to propene, you need to take 2 hydrogens out. In order to go from alkane to alkene, we need to remove 2 hydrogens. Which 2 hydrogens? Any of the hydrogens on one of the terminal carbons at the end and the middle carbon. So remove these 2 hydrogens, it's going to give you this. If you add HCl in your chapter 23, you have a Markov-Nikov rule. When you're adding an HX, X is going to be fluorine, chlorine, bromine, and iodine. In addition of HX to an alkene, the hydrogen with the carbon with more hydrogen will grab hydrogen. So we say hydrogen-rich carbon gets richer and gets carbon and it gets hydrogen, and halogen will go to the other carbon. So at the end you'll have CH3, CH. This carbon will grab Cl, and the other one will grab the third. We'll have the hydrogen, 3 hydrogens. So the formula that shows this compound is formula C. Question number 8. What category of hydrocarbons contains a carbon-carbon triple bond? You can consider it the easiest question. Which one? Alkynes. So C is the correct answer. That's the definition of alkynes. They have a triple bond as their functional group. Okay. Question number 9 is asking which of the following formulas represent propane? We just talked about it. Propane, first of all, the ending of names shows the categories. So propane is an alkane, means all single bonds. And propane means 3 carbons, all single bonds, and around each carbon we must have a complete octet. So we first put 3 carbons, and then we go ahead and put enough hydrogens. This carbon out of 4, each carbon must have 4 bonds. Out of 4 bonds, you have 1, so you need 3 more hydrogens. Out of 4 bonds, you have 2 already here, so you need 2 more. And out of 4 bonds, again, you have 1, so you need 3 more. So you can say this is CH3, CH2, CH3. and this formula is in D. So the answer is D. Question number 10 is asking for what is the general structural representation of an aldehyde. If we have learned the functional groups well, an aldehyde is RCOH, which you will learn in details when you go to organic chemistry, any of you who need to take organic chemistry. So D is the correct answer. More light in the room. Okay. All right, question number 11. 4 of the following compounds are structural isomers. What is the definition of structural isomers? Structural isomers have same formula but different arrangement. So if you check for A, you have how many carbons? 6 carbons. And how many hydrogens? I see 12 hydrogens. So the formula is C6H12. For the rest of them, if you count the carbons and hydrogens, you will have C6H14. So the rest of them are structural formulas except for A. So A is the correct answer. Question number 12. What is the molecular formula of a straight chain alkene with 8 carbon atoms? We are talking about alkenes, and we are supposed to know these general formulas. For alkenes, formula is CnH2n. So if you have 8 carbons, N is the number of carbons. How many hydrogens should you have? 2 times N, 2 times 16, 2 times 8 is 16. So you will choose C8H16, which is D. Answer choice D. We definitely need to know the formulas for alkanes, alkenes, and alcohols. Question 13. In the ejection of a beta particle from the nucleus, which of the following occurs? A neutron is converted to a proton and an electron. Let's try it. A neutron is this, right? I told you you need to know these very well. A neutron has a mass of 1 and no charge. A beta particle has a -1 charge, and this answer choice A says a proton and an electron. So a neutron is converted to a proton and electron. So this is electron, right? Beta particle or electron, that's the same. And proton is 1 and 1. So let's check, is it balanced? 1 and 0 is 1, 1 and -1 is 0. So without bothering to go to the other choices, A is the correct answer. Question number 14. Question number 14 is telling you the rate constant for the decay of radioactive isotope is, so the rate constant is 4.226 times 10 to -3 per day. What is the half-life of this isotope, which you should use this formula? This formula will be given in the exam, although it's very easy. So it's 0.693 divided by 4.226 times 10 to -3 per day. And it seems like the half-lives are already given in days, so you don't have to convert it to anything else. By just a simple division, we'll have 164 days. Which choice is giving you 164 days? D again. So that's the correct answer. Question number 15. What is the correct structure for 1-methyl, 4-propyl benzene? It's testing your skills in structures and naming. When we are going from name to the structure, we always look at the end. Benzene. We need to know the structure for benzene is this hexagon with a circle in it. Then let's go ahead and number our carbons around the ring. There is 1 methyl on the first carbon, CH3. We need to know these substitutes: methyl, ethyl, propyl, isopropyl. And on the 4th carbon, we have a propyl. So if we have memorized the formula of propyl well, this is our propyl. In every carbon, the octet is complete. Around each of these carbons, whether in the ring that you don't see there is a hydrogen, we don't show it, or on each of these branches, we make sure to have the complete octet. So this is the correct answer, which you show this structure in answer choice A. Okay. Let's see what is question 16 asking. Question 16 is asking, what is the expected product from the reaction of 2,3-dimethyl-1-pentene with hydrogen gas? So 2,3-dimethyl-1-pentene plus hydrogen gas. So seems like we have an alkene, so we are saturating, we are adding hydrogen to its double bond. But first we need to know how to draw this double bond. Pentene, I told you, when you go from the name to the formula, you go with the end of the name. Pentene means how many carbons? 5 carbons. So put 1, 2, 3, 4, 5. Let's put this branches, and then at the end we go ahead and complete the octet by putting enough hydrogens. 2 and 3 dimethyl. So if I number them from left to right, 2 and 3 are carrying 2 methyl groups. 2 and 3 doesn't matter if you put the methyl groups on top or on the bottom. And you have 1 pentene, means the double bond is between carbon number 1 and carbon number 2. So out of 4 bonds, you have 2 bonds on this carbon. You need 2 hydrogen, we show it here, CH2. 4 bonds are complete here. 3 bonds, so we need a hydrogen here. And here between carbon and this carbon, you have, this carbon you have 2 bonds, so you need 2 hydrogens, and here you need 3 hydrogens. So it seems like the hydrogens are going to be added to this side. H2, 1 hydrogen atom to this carbon, 1 hydrogen atom to this carbon. So you will have CH3 instead of CH2, you have 1 hydrogen here and 1 hydrogen here. And then CH3, CH, and the rest is the same. CH3, CH2, CH3. And now let's name the compound, since only the name of the compound is given to you. We name a number closer to the first branch. From left to right, methyl is on the 2nd carbon. From right to left, methyl is on the 3rd carbon. So you number from left to right. So let's name the number and then name the branches. Seems like 2 of the branches are the same. So both of them are methyl. But where are they located? On the 2nd and the 3rd carbon. Between numbers, we put a comma. Between numbers and letters, we put a single dash line, space, a slash. So you need to put di because both of them are methyl. So between the 2 numbers, one more time. comma, and then between number and letters you put a dash. If I said slash, I corrected a dash. So between letter and number. Dimethyl, because both of the groups are the same and you have to mention 2 methyls. So you're done with the branches, and then 1, 2, 3, 4, 5, name the skeleton. Is it pentane? So 2 and 3, dimethyl pentane. Which one is it? B. Answer choice B is the correct answer. You need to do the namings and the structures step by step. Question number 17. What is the IUPAC name for the following structural formula? CH3, CH, CH2, CH3. Then you have CH, CH3, and CH3. So we need to name the longest chain, and longest chain is not necessarily straight chain. So we will go with 1, 2, 3, 4, 5, because if you consider it this way, first of all, this is the shortest chain. This way you have 4, but this way you have 5. And we start numbering from closer to the first branch, because this is a branch. If you consider this as the longest chain, 1, 2, 3, 4, and 5. If you consider it as longest chain, 1, 2, 3, 4, 5. So these 2 are our branches. If you number from top, 1, 2, 3 gets the first branch. If you number from the bottom, the second one gets the branch. So you start from the bottom. 1, 2, 3, 4, and 5. Now let's name it. The branches are in the second and on the third one, and they are the same. So 2 and 3, dimethyl pentane. And I chose these 2 questions right after each other, so you will see that in the previous one you had a straight chain. Now if you just play with it a little bit and fold it, you have the same compound but not completely straight. So the correct answer is going to be E. Question number 18. This question is about chapter 20. A radioactive isotope undergoes decay by emission of positron. After 2 hours, T is 2 hours, 6.650%, 6.650%, which is NT, of the initial amount of the isotope remains undecayed. What is the half-life? So we always change the percentage. You divide it by 100, it gives you 0.0665. And you have this formula, ln NT over N naught is minus KT. What are we looking for? T half-life, because the formula is this. Before finding half-life, you need to find K. You will find it from this formula. So you will have ln of 0.0665 is equal to minus K times. If you look at the answer choices, they're all in minutes. So 2 hours is 120 minutes, right? Times 120 minutes. Get the ln from the left side, which is minus 2.71, equals to minus 120K. So K is going to be 0.025. 23. And then plug into this formula, T half-life is going to be 0.693 over 0.023, which gives you 30.1 minutes. Let's look at the answer choices. 30.7 minutes, which is the closest. We choose it as the correct choice, which is B. Question number 19. Question number 19 is asking, the half-life of phosphorus is 25 days. So half-life is 25 days. How much of a 128 gram sample will remain after 160 days? So the original sample is, I'm sorry, it just doesn't need the bracket. If I put it last time, you don't need it. And naught is 128 grams. And T is the question, and T is 160 days. So first we need to find the rate constant, 0.693 over K. Then K is 0.693 over T half. Cross multiplication, and K is going to be 0.693 over 25 days. It will give you 0.027 per day. Then we have ln NT over N naught, which is 128 grams. Is equal to minus 0.27 times per day times, what is T? 160 days. So, and T is going to be about 1.5 grams. Let's see which answer choice is the closest, which is A. Question number 20. What is the condensed structural formula for tertiary butyl T-butyl? One of those substituents that you need to memorize. T-butyl is means tertiary butyl. There's no other ways at this point to know the formula except for memorizing it. We call it a tertiary carbon. You will learn it more. And then this is a tert butyl. Which one shows the tert butyl? C is the correct choice. And finally, question number 21. Which particle has the same mass as a beta particle? Beta particle, it has a -1 and 0. A neutron is 1 and 1. I'm sorry, it's 0 and 1. A proton is 1 and 1. Gamma ray is 0 and 0. And alpha particle is 2 and 4. And finally, positron is, we say the same as alpha, but instead of negative, it's positive. So that's a positron, or E. I hope this review was helpful. Good luck with your studies.